Welcome to Tensor Lens. So, get this. What if the next giant leap in technology isn't about inventing something brand new, but about getting really, really good at copying? We're talking about looking at nature's most successful designs, things that have been tested for millions of years, and using them as the blueprint for the future of AI and robotics. It's a pretty wild idea, right? So, what is this idea called? Biomimetics. And really, at its core, it's just about learning from the ultimate R&D lab, nature. I mean, think about it. It's like we've been given access to a 3.8 billion-year-old design library, and inside are the solutions to some of the toughest problems we're facing today. All right, so here's the plan for today. We're gonna start small, really small, and look at how we're building an artificial brain. Then, we'll give it a super efficient eye. After that, we'll see how these pieces come together in actual humanoid robots taking their first steps. And to wrap it all up, we'll zoom way out and check out the massive multi-billion-dollar gold rush that's happening right now because of all this. All right, first things first, we have to tackle this huge, kind of weird problem. The computers we all use, yeah, they're lightning fast for some things, but when you compare them to the human brain, they're just shockingly inefficient and fragile. This isn't just a small issue. It's become a massive bottleneck, the one big thing really holding us back from creating truly smart, adaptable AI. So what's the brain's secret sauce? Well, it comes down to this incredible feature called intrinsic plasticity. Now that sounds complicated, but the idea is actually pretty simple. It means that every single neuron in your brain can basically adjust itself on the fly. Think of it like an orchestra where every musician can tune their own instrument in the middle of a song without the conductor telling them to. The result? The entire system is just unbelievably adaptive and resilient. Okay, and this is where things get really cool, where science fiction starts to feel like fact. On the left, a good old-fashioned biological neuron, and on the right, its artificial twin. Scientists have figured out how to recreate that biological magic in silicon. They're using this tiny little component called a Neuristor, and what it does is it cleverly combines two things called memristors. You can just think of them as resistors that have a memory, to perfectly copy how a real neuron fires and adapts. It's just amazing. But here's the real kicker, the part that's an absolute game changer. We're talking about hardware that can literally heal itself. Look at this process here. If a part of the network gets damaged, let's say a neuron gets knocked out, the other neuristors just adapt. They figure it out on their own. They reroute the signals, kind of like your GPS finding a new way around a huge traffic jam. And the result? The whole system gets back to full performance. This is it. This is how we build AI that's not just smart, but genuinely resilient. Okay, so we've got a component that can think like a brain. That's a huge step. But, for it to actually be useful in the real world, it needs to see. And guess where we're looking for inspiration for a better eye? Yep, we're going right back to nature. And this right here really nails the problem with the cameras in, say, your phone. On the left is how they work. They just capture everything, the whole scene, over and over, 60 times every second. Think about all the wasted energy and data processing that static background, like a wall. It's nuts. But our eyes don't do that, and neither does the tech on the right. These things are called event sensors, and they are a total paradigm shift. They work just like our own retinas. Every single pixel is its own little agent, and it only reports back, it only sends data when it sees something change. They call it an event. So instead of capturing gigabytes of boring static background, it only captures what matters, motion. And it does it with microsecond precision. It's just so much smarter. So what does this nature-inspired approach get you? Well, how about a massive, almost unbelievable jump in efficiency? We're talking about these sensors using about 1/10 of the power of a normal camera. That's not just a little better, that's a 10x improvement. And that is absolutely crucial for anything that runs on a battery, right? Think drones, mobile robots, AR glasses. This changes everything for them. Okay, so let's recap. We've got a resilient, brain-like component. We've got a super efficient, retina-like eye. What's next? Well, you put them together in a body, of course. Now we're getting into robotics, and we're gonna see the machines that are literally walking out of the labs and into the real world as we speak. Right now, what we're seeing is nothing short of a Cambrian explosion for humanoid robots. And this TV gives you a great snapshot of the landscape. They're not all being built for the same thing.
You've got the heavy hitters like Agility's Digit, built for warehouses. Then there's FiguresBot, which is all about fine motor skills for manufacturing. But what's really blowing my mind is the other end of the spectrum. Robots like the Unitree R1 that are so affordable, they're opening this field up to almost everyone. And let's be clear, this isn't just about cool YouTube videos anymore. These robots have jobs, real jobs. The Figure robot, it's on the factory floor at BMW right now. Agility's Digit, it's moving totes around a Spanx warehouse. And others, like For Real's GR1, are even working in healthcare, helping patients with physical therapy. The commercial value is already here. It's being proven as we speak. Okay, but we gotta pump the brakes for just a second and get real. A lot of those jaw-dropping demos you see online, a good chunk of them are still using something called teleoperation, which is basically a fancy way of saying there's a human with a controller somewhere pulling the strings like a puppet master. So while the hardware is amazing, getting these robots to be truly autonomous in our messy, unpredictable world, well, that's still the final boss everyone is trying to beat. So when you have a technological leap this big, what comes next? You guessed it, a gold rush. We are seeing a massive, high-stakes race to invest in and build our future robot helpers. And the amount of money flying around, well, it's just staggering. I mean, just take a look at these numbers from Goldman Sachs. They're forecasting the market to explode from about $2 billion today to over $38 billion by 2035. That's almost a 20 times increase in a little over 10 years. That curve is basically a straight line going up. And the crazy part is, analysts keep having to revise their forecasts because things are moving even faster than they expected. And it's not just public market forecasts. The private investment scene is absolutely on fire. Agility Robotics, yeah, the company putting robots in Spanx, is already valued at more than $2 billion. And you know this is serious when you see who's investing. We're talking about giants like Amazon and Nvidia placing massive bets. That tells you this is way beyond just hype.
And make no mistake, this is not just a Silicon Valley game. The competition is fierce and it's global. Unitree, the Chinese company that absolutely stunned everyone with that super cheap robot, is now apparently gearing up for a $7 billion IPO. Their playbook seems pretty clear. Come in with aggressive pricing and try to own the mass market.
But look, this race is not a cakewalk. There are some serious hurdles to overcome. First, you've got to figure out mass manufacturing, going from building a few hundred robots to building thousands or even millions. Then there are the supply chain headaches, things like access to rare earth metals. And of course, there's the big one we already talked about, cracking the code on true go anywhere, do anything autonomy. And all of this brings us to one last big question to leave you with. As we get scarily good at building machines that look like us, that move like us, that even think like us, all by using nature's own blueprint, what's the one thing about us, about being human, that we can never replicate in silicone and steel? All right, that's what we've got for this explainer. You know, if you find this stuff as fascinating as I do, and you want to keep digging into the technology that is literally shaping our future, do us a favor and subscribe to Tensor Lens. We'd love to have you along for the ride. Thanks so much for watching.